Hello, welcome to By Excellence Tutorials. And at By Excellence Tutorials, we do offer tutorials to university students in courses like mathematical methods, physics, chemistry, biology, statistics, and many other courses. We also do one-on-one tutoring. So if you're looking for tutors to tutor you one-on-one, exhaustively online, you can get in touch with us and we are going to be able to help you. Well, have you yet subscribed to the YouTube channel? If you have not yet subscribed to the YouTube channel, kindly click on the subscription bell, subscription point, and then you also make sure that you click on the bell so that you get notified each time I upload or we upload new content. Well, today we are going to look at mathematics, of course, and this mathematics, we are basically zeroing in on calculus. Okay, so we'll start from the first part, how to apply first principle, and we go down into calculus, into integration, differentiation, and all those things. Okay, so when you are looking at calculus, first, before we start looking at the first principle, when you are looking at calculus, I must mention that you are looking at the study of concepts of the rate of change of a variable with respect to another variable. Okay, that is what we are basically looking at under calculus. So now, the first principle, we are not going to derive it, how we come about first principle. Of course, we know that we have a curve between the point, we draw a tangent, and then the rate of that tangent, blah, blah, blah. No. So the first principle, like this one, is given by the limit of h approaching 0. So this is what we are going to use, the h. In some other books you use delta chronicle, but here we are going to use h. Okay, then we have function of x plus h minus f of x over h. Okay, so that is the first principle. So now, how do we get to apply this principle? Okay, so we are going to solve a number of questions, and then you know that you are going to be able to understand how we apply this one. So first of all, let's say we have a function. Okay, we have a function f of x being equal to x squared. Okay, so how do we apply this function? The first thing that you need to do is to substitute, okay, is to substitute x plus h for x in the given function. So we say substitute x plus h for x. So this will give us fx plus h is going to be x plus h squared. So we are substituting. In short, we are saying where there is x, we substitute with x plus h. Remember that the function is f of x. And then there is, with time, there is a small increment, which is h. Okay, so h is just a small increment. That's what it means. Okay, it's a small increment with time. So now where there is x, we substitute with x plus h. So you can see that in the original function, we have x squared. Okay, we have a function x squared. So we substitute where there's x with x plus h. So you're going to see that that x plus h is going to have a square. So this, when you simplify this one, or when you expand it, it's going to give you x squared plus 2xh plus h squared. Okay, so that is the f function of x plus h. And then function of x is x squared. We already have that one. So we substitute in the first principle expression. So we have limit of h approaching 0. As h approaches 0, we have function of x plus h is this one that we have simplified, which is x squared plus 2xh plus h squared over h, sorry. So it continues, say minus f of x. So minus x squared. Okay. So we are going to have the limit as h approaches 0. We can barely see that we have x squared here and negative x squared. So these, they subtract and you get a 0. So we are going to have 2xh plus h squared over h. So we just now factorize, we factor out the h. So we're going to have h outside and 2x plus h over h. So that h on the denominator and h on the numerator cancels, and then we have limit of h approaching 0, 2x plus h. So that means that where there is h, we put a 0, we substitute with a 0. So we are going to have 2x plus 0, which we're going to have as 2x at the end of our solving. So it means you have differentiated x squared using first principle. So 2x is called the derivative of x squared. Okay. We look at another example of the application of first principle. So let's say we have a function f of x equal to x over x minus 1. Okay, so how do we solve this one? So of course, again, we substitute x plus h for x. So the function of x plus h after a small increment, after a small change, is going to be x plus h over x plus h minus 1. Wow. Okay, so we get back to our first principle. I'll write it in case you've already forgotten. It's written like that. So it's replacing now where there is the function of f plus h, we substitute with that. So we have x plus h over x plus h minus 1 minus f of x is x over x minus 1. And then the whole lot of this is over h, like that. Okay. We go on and to simplifying this one. So we find the lowest common multiple of these fractions that we have on the numerator. And then we're going to say that is basically, or it's the product of those denominators. So that into that, okay, so, and this all is over h. So x plus h minus 1 into the whole of that denominator is going to give us x minus 1. So we have x minus 1 multiplying by the numerator, which is x plus h. And then here we are going to have minus x, also multiplying that. Okay. So what are we going to have? So what we're going to have, we're of simplifying this. So we're going to have x by that, we have x squared plus x minus h. We come there also minus x squared minus xh plus x plus h minus 1 over h. I hope you have h approaching 0. So we can look at this and cancel this and that. They are canceling. And then we also have minus x plus x canceling, minus xh plus h over x minus 1. And this is over h. Going to be h minus 1. So h and h is cancelled. So now we have arrived at this, and then we are going to have negative 1 over x. Yes, so it's going to be plus x minus 1 minus 1, the same as x minus 1 squared. So this is how you get to, to find the derivative of that one. Now you can yourself, if you have really understood by differentiating using first principle, pause the video for a while, even 1 minute, and see if you can be able to solve that one. Okay, welcome back. I believe you have solved that one. So now, how do we solve that one? So this one is also the same way we have been dealing with. X plus h is basically going to be x plus h. Limit h approaching 0 is going to be minus x over h. This 0 is going to be x minus x is going to give us 0. So this one is the simplest, okay? X minus x gives us 0, and we have h over h, of which this one is going to be h over h is 1. So 1. So basically we have a 1. So this is how you solve. I believe you solved it this way. That's how you do with derivatives. Okay, so there's this question that we can solve together. Okay, the first one is saying find the derivative or differentiate using first root x. Okay, so we're going to find the derivative of this guy, saying for x is greater than 0. So we've been given also in the range. Okay, and the second question under the same, find the tangent so the gradient at x equal to 4. Okay. Oh, sorry. So it ends somewhere there. Okay. So how do we get to that? So we are still using the first principle. Okay. So we're saying, according to first principle, f will be x plus h under a root. So now we have the limit of h of x plus h that over h, like that one. Okay. So if you look at that one has got what we call sides, and for you to solve this one, you must be able to rationalize. Okay, so how do you rationalize? Is finding first the conjugate of that numerator, of those radical, or that radical expression that we have on the numerator, and that conjugate we are going to multiply it by the numerator and also the denominator. By so doing, we're going to rationalize the numerator. Okay, so what we're going to get, the conjugate going to be x plus h plus root x. Okay, so the original has got a minus, so the conjugate is going to have the plus there. So we are going of h approach of x plus h x plus h plus k. So we have that one. So we multiply. So once we x plus h, then that by that we are going to get okay, and then we have minus x over h. Okay. So what we have now is 0. So we are going to have limit of h approaching x minus x gives us 0. So we're going to have that h and that h approaching 0. We have 1 root like that. So we substitute to have we substitute. After substituting, we're going to have 1 over root x. So plus root x, and that is going to give us 1 over 2 root x. The derivative of root x is 1 over 2 root x. Okay, so now there is another part of this question which happens to be so interesting. Yeah, it's an interesting case that we must also find the tangent line to the curve of y equal to root x at x equal to 4. Okay. At x equal to root 4. So now remember that this first principle is basically giving us the gradient of the curve. Okay, because you have like a curve, you have a curve, and then you draw a tangent to get the gradient, how steep the line is. Okay, it is out of the same differentiation. So once you differentiate a function, you're able to get a gradient of that function. So here we are going to use this same one that we are just from differentiating to get the gradient. So the gradient, and then we substitute at what point it is when x is equal to 4. That's the gradient we want to know. So 2 times root 4 is 2. So we have 1 over 4. So that is our gradient at that point of x equal to 4. So since we have gotten to know the gradient, now the function is y equal to root x. Okay, y equal to root x. So how do we get to know the points? The points we've been taught to say when x is equal to 4. So we have one coordinate already. We have 4, x equal to 4. But for us to plot a point, we must have x comma y, or 2 coordinates for x and for y. So now, how do we get the coordinate for y? It's just substituting the coordinate of x into the expression, to the function, and then we get the coordinate of y. So 2. So the point here, and the gradient is 1 over 4. So it's more like you're dealing with coordinate geometry. Okay, so now how do we get the equation of the line? In this case, we have y x minus x1, like that. So the gradient is 1 over 4. Multiply, we're going to have that. I is going to be 1 over 4x. We take the negative to the other side, it will be positive. So we're going to have plus 1. So this is actually the tangent line. So that is how you get to solve that one. Okay. I hope you are understanding. You are getting it. Let me see if we can solve one more question. Or maybe this will be your task. Give you a task. So solve this function 2x squared. So this one is your task. It's not difficult because we've already differentiated the function like y equal to x squared. So it's going to be simple. I've just added a constant in front of x squared. Okay, so this will mark the end of our session today. And in the next session, we're going to continue with differentiation. And basically there, we're going to look at basic differentiation rules, where we'll look at power rule, chain rule, quotient rule, product rule. Okay, so watch out for the next video. Thank you so much for your time, and I hope you enjoyed. And don't forget to click on the notification bell since you have already subscribed, so that you get notified when I upload the new content.